Hi, good afternoon, EDCON. Good afternoon, developers. So I'm Nicolas Bacca, CTO of Ledger, and this afternoon I will give you a short presentation about hardware wallets and how we can use them for Ethereum smart contracts and how we can improve the status quo, I would say, of security and how hardware wallets interact generally with smart contracts. So first, a few words about Ledger. I would say that we are providing a trust layer between the physical world and a blockchain, which means in details that, well, we will control things that get in and things that get out. So for more details, this can mean several things. In the case of hardware wallets, well, we are basically securing the chair keyboard interface. So what gets in is the transaction that you want to send. What gets out is the signature of the transaction. For HSMs, for example, on servers, we are validating different signature policies as well, applying quotas, and making sure that if your exchange got hacked, the hacker is not going to get away with the full content of your wallets. So we can provide kind of more secure hot wallets, for example. For IoT, we can control data as well, making sure that sensors will act on predefined policies and control that data is not completely meaningless. So, for example, if you are monitoring an electrical meter, you will make sure that you are not connected to a nuclear power plant and that it's not, that, for example, a solar processing plant is not going to generate a lot of electricity at night. Well, it can be used for all kinds of security, and we are providing those options in, I would say, the most open way possible. So today I will be focusing on hardware wallets. Since hardware wallets are a pretty new field in Ethereum, I will just give a very high-level summary of what is a hardware wallet. I consider that your interface with the external world, so your PC, is pretty much broken. So maybe not that broken, but close enough, at least internally. So internet is an hostile world. You can have malware, you can have viruses on your PC, you can have things trying to spy what you are doing or just trying to steal your keys. So you are going to connect a dedicated hardware through USB, for example, to your computer that will allow you to perform verification of what you are doing and to show that you are basically approving an operation. And this operation will work completely in the device and making sure that you are not leaking any cryptographic material. Because one of the problems with malware, typically, even if you are using, for example, encrypted vaults or encrypted data to store your keys end up in RAM, and when they are in RAM, they can be stolen. So the goal of the hardware wallet is to avoid this last scenario. So short history about hardware wallets. Initially, everything began with a smart card. So the smart card is not really something for the general public or for hackers, I would say. You are using it already without knowing it maybe. So you have a SIM card, you have a banking card if you are European, or if you live in the US recently, you have smart cards as well. It's absolutely not convenient. So it was impossible to connect to a PC. You need an additional reader, and that's why, for example, in France, we were leading the smart card market for e-commerce, but you would never be able to order anything on your PC because, well, technically speaking, it would have been great for security, but it didn't make sense to have everybody buy a new reader. So it's good to host secrets, but it's not designed at all to operate in a hostile environment. Because the smart card doesn't let you verify anything, so it's just an oracle that will perform secure computation, give you a result, but if a malware is pushing you something, then you have no way to detect what happened. And it's not developer-friendly at all. The most developer-friendly environment is Java card, which is, well, Java with a very low amount of RAM, so pretty much not usable. You don't even have strings in this API, so, well. Small improvement that took only 25 years to appear. The same thing with the USB interface. So the USB interface solves the reader problem, but then it's still not designed to operate on a hostile environment. Because if, for example, here, using a YubiKey, you will get a notification when you have something to perform, so you will get a blinking YubiKey, which is nice because you know that you have something to do, so you will perform something, but you still don't know what you are doing. So you just prove that you're there, but that's it. So it's okay, it's better than before. At least it's easy to connect to a PC, but it's still not great. Then with cryptocurrencies appeared the hardware wallet and a lot of different objects in this ecosystem. So surprisingly, for something that's very new, you already have a lot of people manufacturing this. So counterclockwise, I have Case here, Trezor, KeepKey, Cool Wallet, and us. So we are basically the only one to continue the smart card thing. So we are building our projects on top of smart cards. CoolBTX is doing the same thing. Well, because smart cards are good to protect secrets, others took other choices. We can discuss that after a few beers if you want. Here, the idea is that the hardware wallet is definitely designed to operate in an hostile environment because it will display what you are doing and you can act on it. So the idea here is to have the most precise display about what you want, which is quite important for smart contracts, as we'll see. So why did we have all these objects appearing specifically for cryptocurrencies? Because cryptocurrencies are very attractive to hackers. When you steal crypto, you can walk away, nobody will know anything. It's a famous sorry for your loss. Well, you lost something, nobody can do anything about it, but everybody can be sorry and that's it, nothing else. So you can lose your keys, that's the easiest way to lose crypto. You can get it stolen by malware or viruses. You can lose keys as well just because an attacker doesn't like you and want to harm the network. We have seen this with the DAO, for example. And you can even have more complex, I would say, schemes that will allow someone to steal keys or to steal some crypto from you. That I'm calling here some new kind of ransomwares. Let's say that you are operating with a hardware wallet. Your hardware wallet is generating keys based on the BIP32 Bitcoin scheme. Sorry. So BIP32 derives keys from a common seed, and let's say that deriving keys on a path, here, a malware will just insert some entropy into your path. So you are still deriving keys to yourself, but in the end, you are just deriving keys to a path that you don't know. So you are, in the end, your own thief. You derive keys, you don't know where they are, and someone can steal this information from you. So in the end, you are still operating on secure material, you are not leaking keys, but somebody can steal money from you. So that's kind of an elaborated attack. Just to remind you that when you design secure environment, you have to remember, you have to think about those kind of attacks when you do that. So what do we need to interact safely with smart contracts? At the minimum, you need to verify that you are performing the right action with the right contract. I would say as an extension, you can give more insight into exactly what you are doing. So you can try to maybe display some additional things about the contract. I will see an example with ERC20. It might not be necessary for all contracts, or you can have some completely different UI. If your contract is complex, I would say, you may want to display to the user some information that makes sense. For ERC20, one of the problems is that, well, you have the ABI of ERC20, you don't exactly know which address you are talking to because the hardware wallet, of course, is disconnected. So you have to make a relationship between the ABI and the address. Here, well, when I am sending money to this address, it's an ERC20 test token called Unicorn Coin, so which is not expensive. You can generate them for free. You verify that you are communicating with the transfer function because you have the function, you have the ABI. You are verifying the destination address, so you can display this if you know how ERC20 works. And then you have an amount with decimals here. Problem is that that amount of decimal is designed when you create the instance of the contract. So if you don't have this information here, you cannot act on it. Which shows that even knowing the ABI is not enough in that case. I've started to think about a proposal so to, well, at least make the ABI, link the ABI back to the contract address and have the hardware wallet act on it. The idea would be to have a binary version of the ABI, provide the nonce that let people verify the contract address, so that lets the hardware wallet verify the contract address, sign this by the issuer, so that we can provide it to the hardware wallet and have kind of a decentralized and, well, at least trustless, if you only trust the contract developer key, to have the hardware wallet verify it. Just an example, so it's completely up to discussion. You can create your own applications as well using our hardware wallet if you need to. So we have an isolated system that lets you write your own applications. And if you're interested, you can, well, dig in. We have an SDK available. We have a Slack. You have example of how we integrated ERC20 into our generic Ethereum application if you want to have a look. And, well, that's it. If you want to join me, I'm available on Twitter. If I want to join you, I have your email and your phone numbers already, so thanks.